Two identical capacitors A and B are charged to same potential V and are connected in two circuits at t is equal to 0 as shown in the figure. Charge on the capacitors at t is equal to CR respectively. So this is RC circuit. Time constant tau is t here, which is equal to RC or CR. So this is the time in which current becomes 1 by E of the optimum value, 1 by VE of the optimum value. So that is, we will keep it in mind. Figure 1, if we analyze, the diode is forward biased. Diode is forward biased. So there is current flow through the diode. So at T is equal to RC, the charge in the capacitor Q becomes Q naught by E. Q naught by E. So when it is charged, it is CV. So the charge on the capacitor becomes CV by E. CV by E, because this is the time in which we are measuring the charges across the capacitor is the time constant, in which current decreases, as I told you, I naught, current decreases by a factor 1 by E. Okay. In figure 2 what happens is, see, this is reverse bias, no. So this circuit, what happens, this becomes open. This is reverse biased. So this diode, since it is reverse biased, the circuit suddenly becomes open. It cannot conduct current. Diode is reverse biased. So the circuit is open. Circuit is open. So there is no current flow. So the charge Q dash remains Q itself, that is CV. So in figure 2, the charge remains CV itself, and in figure 1, the charge across the capacitor is CV by E. That is option B. That is option B is the right answer.